Morning, everyone. Thanks for coming. So I'm going to be talking about developing an analytical framework for estimating the impact of these more sensitive tests. As Gonzalo mentioned, a high sensitivity test has been released, and there's a few more in development. Conventional RDTs are still very effective at diagnosing clinical disease, but often they miss lower density infections. So the idea is whether these high sensitivity RDTs can be used to detect these infections. RDTs are used programmatically by national malaria control programs and in trial settings for a range of different purposes, such as reactive case detection, screening pregnant women, prevalence surveys, and mass test and treat interventions. So what we're trying to do here is bring together data from all the studies being conducted at the moment to try and understand the impact of these high sensitivity RDTs in different transmission settings and with different use case scenarios. So the two main aims. Number one is to try and bring together data to estimate the performance of these high sensitivity RDTs in different transmission settings and in different populations. And then number two is to try and assess the impact of this HS-RDT on burden and transmission reduction in different use case scenarios. So this is some data. So these are, most of them are cross-sectional prevalence surveys. Two of them are reactive case detection prevalence estimates. On the x-axis, we've got PCR prevalence, and on the y-axis is high sensitivity RDT prevalence. The dotted line going up diagonally is the line of equality. The grey line is a fitted relationship from a paper by Lindsay Wu, which is the PCR conventional RDT relationship. And each of the dots represents a prevalence estimate by these two measures in different surveys. I think there's a couple of interesting things to point out here. So number one, this is from a really great study by Natalie Hoffman, who's in Ingrid Folger's lab, looking at prevalence in Papua New Guinea. And here so these two prevalence estimates are from exactly the same individuals, and it shows you actually PCR is quite a subjective measure because the one on the left is a more conventional PCR, and the one on the right is really, really high sensitivity PCR. So even though they're testing on the same people, they're finding twice as much infection. Also, a really nice study by Jordi Landia in Myanmar. So here he tested HS-RDT on the same individuals in a lab and in a field setting. And the orange one is the lab setting, so you can see that under idealized conditions, the HS-RDT is slightly improved compared to using it in a field setting. But I think hopefully the most exciting thing to notice from here is this grey line is what we think PCR-RDT relationship is, and all of the points, apart from the green one, are above that line, so indeed better than RDT. And we can look at this a bit more closely. So here we have, each of these studies also used a conventional RDT. So here the solid dot is HS-RDT, the open dot is a conventional RDT, and then the height of the vertical line is the percentage point increase in performance from using a high sensitivity RDT. So you can see generally, especially in the higher transmission settings, you're getting about a 10 to 15 percentage point jump in the number of infections you'll be detecting in a population. Less increases in the lower transmission settings, but that's just because there's not many infections to be detected. So that previously was just cross-sectional prevalence surveys. Now we can look at it a bit more. Let's look at it by taking just the PCR prevalence surveys. So previously there would have been some discordant results, so PCR positive, HS-RDT negative, or vice versa. And now we're just interested in, if we take all our PCR positive individuals, what proportion of them are going to be positive by the HS-RDT. So that's what we've got on the y-axis, proportion of PCR positive infections detected by HS-RDT. I don't think there's a very clear pattern for me to describe in this picture. It's kind of all over the place. Really big confidence intervals at the very low transmission settings, just because you have to do so many tests in order to find some positives. But generally, the performance is hovering around maybe 40–50% of PCR positive infections are being detected. Okay, so the next question is, so if we think we're going to be finding additional infected people in the population, how does that translate to the proportion of the infectious reservoir that's going to be detected? So as of yet, we don't have any data available to us showing the relationship between HRP2 concentration, detectability by HS-RDT, and infectivity to mosquitoes. But we can try and get at this exact question by using two data sets and trying to bring them together. So the first one is... So this is some data from Uganda, by a paper by Smita Das that came out a couple of years ago. So here this is asymptomatically infected individuals in a population, and their parasite densities were determined by qPCR. So I've binned all these individuals by their qPCR densities, and then I've counted in each of these groups what proportion of them are detectable by RDT and HS-RDT combined. So that's the darker colour. And then the bit at the top, the lighter shaded bit, is the additional people that will be detected on top of an RDT by using an HS-RDT. So the first thing you'll notice is that actually conventional RDTs are pretty good at detecting people with loads of parasites, as you'll expect. But the place where that HS-RDT is really bringing some value is in these, what we traditionally call submicroscopic or subpatent or low-density infections. So in the 1 to 100 parasites per microliter range, HS-RDT is detecting about twice as many infections as a conventional RDT. But next question, how infectious are these infections? You might expect them to be less infectious. Fewer asexual parasites, fewer gametocytes, less chance of infecting a mosquito. So we can use another data set. This is a paper by Vonner Goncalves out of Chris Drakeley's lab, published in NatComs a couple of years ago. So this is data from Burkina. So they got asymptomatic individuals in a population. They quantified their parasite densities by qPCR, and then they also fed their blood through a membrane feeder to mosquitoes. So then you could sort of see the relationship between how parasitemic someone is and how infectious they were to mosquitoes. So what we did here, we just sort of ranked all the individuals by their qPCR parasite density, and then if you take a group of individuals with parasite densities above a certain threshold, you can count what proportion of total infected mosquitoes were infected by individuals with that higher parasite density. So this is kind of like a cumulative, cumulatively how much of the infectious reservoir are we detecting? So we think previously we maybe were detecting around 100 parasites per microliter. So here we're estimating that 67% of the infectious reservoir is going to be detected. So i.e. if you were testing and treating everyone above that level of parasitemia, you'll be clearing 67% of the onwards infectivity to the population. By having a 10 times increase, so going to about 10 parasites per microliter, this has taken us to about 83% of the infectious reservoir detected. And then a 100 times improvement in the sensitivity is taking you to 89% of the infectious reservoir detected. So even though these individuals may be slightly less infectious, by going up higher sensitivity diagnostics, you still are increasing the proportion of the infectious reservoir that you're picking up. So now we're just going to talk through, this is very much work in progress. This is just talking through some ideas about how we're going to try and think about the use case scenarios for HS-RDT and what sort of data we need and what sort of questions we're asking. And there's loads of studies being conducted in these areas at the moment, so this is just like trying to put together a framework preemptively of how we're going to analyse these data. So number one is active case detection. So this has two flavours. So the first one is reactive. So this is the idea that an index case will appear at a clinic, they'll be followed up by community health workers to the household, and then you'll expect a proportion of the individuals in that house and the nearby houses to be detectable by PCR. You'd probably expect a slightly smaller proportion to be detectable by HS-RDT, and then an even smaller proportion to be detectable by RDT. So if you're following up that house and you're doing some sort of screening and treat approach, how many people are you going to be picking up and how infectious are they? So in order to get an estimate of what impact this is going to have on transmission, we first need to know how clustered are infections around index cases and how do we expect this to change in different transmission settings. Then we need to know if we are going to switch from using an RDT to an HS-RDT in this use case, how many additional infected individuals are we going to be picking up? And then kind of looking at it more on a transmission, like population level, by detecting these extra infections using the HS-RDT, are we actually going to be clearing enough of the infectious reservoir to have like an onwards community level impact, or are we just providing like direct benefit to those infected people? And if it's the former, if you are actually knocking down the sort of population level infectious reservoir, that's the point where this actually might prove to be a really useful strategy for moving along the pathway towards elimination. So there's a couple of studies going on, Myanmar, Zambia, I think a few more, so we're going to try and bring these data together to make a model to try and describe this sort of idea to get estimates of the impact. The second flavour of active case detection is proactive. So this is screening and or testing that is not prompted by the detection of a case, but is undertaken in high-risk groups or during high-risk periods. So here, I'm just going to refer back to a graph we looked at earlier. So here, if you're going to go in and do a cross-sectional prevalence survey to get an estimate of how much transmission is going on, this is the increase in performance you're going to be getting from using the HSRDT. So in most settings, in the higher transmission settings, you're going to be picking up about an additional 15 percentage points PCR prevalence compared to the conventional RDT. In the lower transmission settings, maybe not so useful because, yeah, again, not much infection, so you're just going to have to do a huge number of samples to find infected people. And then this also poses another, hopefully, interesting question. So after you are, if you're treated for malaria and you then clear your parasites pretty quickly, with a conventional RDT, you'd be expected to remain RDT positive for maybe 3 weeks. And because the HSRDT is more sensitive, the sort of time to RDT negativity after clearing parasites is going to be much longer. So if you were to use HSRDT as a screening tool at the end of a transmission season, you're kind of going to get more information than you would have done with a conventional RDT, because you're going to be picking up current infections, but you're also going to be picking up some measure of not current but recent infections. So it's just going to tell you a little bit more about how much transmission is happening now and what's happening during the transmission season. So that could be quite a useful application of this test. Mass or focal test and treat, so MTAT or FTAT, currently not recommended by the WHO, but maybe being discussed a little bit more at the moment due to the availability of this HSRDT. So this is some modelling work we did a few years ago. So this was modelling 3 rounds of MDA or MSAT with increasing sensitivity diagnostics. And then on this graph, we're looking at annual EIR, so just transmission intensity. And then on the y-axis is number of years of that intervention it would take in order to eliminate transmission. So the graph is basically saying by improving the diagnostic sensitivity of your screening tool, you are able to interrupt transmission in higher transmission settings, and you're also able to do it quicker. But a result that always comes out of this work is that MDA is always going to be better than MSAT, because not only are you clearing the infections, but you're also just providing mass prophylactic protection to a lot of the population during the transmission season. So yeah, we're going to update this with new data from the HSRDT trials and trying to get a better estimate of what MSAT would look like, or MTAT would look like with this new HSRDT. And it also raises a question, is there like a sweet spot for MSAT or MTAT? I called it both things on one slide, so that's how defined the notation is. In very, very low transmission settings, the sensitivity of the HSRDT decreases, but also in this setting, doing an MSAT approach might be more appealing because you don't want to give out loads and loads of ACTs to people that don't have malaria. On the flip side, in a really high transmission setting, your HSRDT is much more sensitive, possibly, than... but also in this setting, by finding and treating these people that are HSRDT positive, are you finding enough of the infectious reservoir to actually cause that population-level reduction in onwards transmission? So we're using modelling and data to try and see if there's like a sweet spot where MSAT or MTAT is sort of optimally effective. Screening pregnant women, so we've got a talk on this later, so I'm just going to skip over this one quite quickly. Some of the ideas around this are that pregnancy boosts the density of infections, so screening for low density infections pre-boost may prevent parasites replicating in the placenta before a woman will be embarking on an IPTP. So regular screening with a high sensitivity RDT might help you detect these infections before they ever progress to be more severe. From the second trimester onwards, it's thought that existing interventions are already pretty good. And also there's the idea about in HIV positive women, the current drug has limited antimalarial properties. So is there a role for RDTs or HSRDTs so they can be diagnosed and given better antimalarial treatments? Finally, so again, this isn't recommended by the WHO, but this test is available to buy, so it's likely that it will appear in health facilities. So we wanted to look at seeing if we could put some numbers behind how many additional cases are going to be detected by switching to an HSRDT. So if you, this is a schematic, and it's quite far from, take it for what it is. This is the number of people appearing at a clinic, so you'd expect some of them to have malaria fever, and you'd expect some of them to have fever which isn't caused by malaria. And if we look at this non-malarial fevers in slightly more detail, we can actually split them up into different groups. So in a sort of medium, moderate, high transmission setting, you might expect quite a large proportion of them to have asymptomatic malaria, but malaria not being the primary cause of their infections. You'd also expect some of these individuals to have been recently treated, so still being HRP2 positive, and also you'd expect some of these people to just not be infected. So now we're shading in, you can just about see that, but now we're shading in what proportion of each of these boxes we'd expect a conventional RDT to pick up. So RDTs are really good at detecting fever, so we'd expect a lot of them to be detected. Of the asymptomatic individuals, you'd expect RDT to pick up a small proportion, and you'd also expect it to pick up a small proportion of these people that have been recently treated. So by switching to an HS RDT, maybe you'll get a few more clinical cases detected, but you're also going to get potentially a lot more asymptomatic cases detected and a lot more recently treated people detected. So just counting up these shaded areas, this is the addition. These are the people that are being detected with an HS RDT compared to an RDT. And yeah, basically you'd expect more infections to be detected by switching to this test, of which most of them may not have malaria as their primary cause of fever. And we're not saying this is a bad thing. This indeed is likely to be beneficial because you're going to be treating additional people before they go on to develop symptoms or associated comorbidities. But the dynamics of this and the numbers behind this are going to be really dependent on transmission setting, asymptomatic infections, fever, treatment-seeking rates, and seasonality of transmission. So we're going to use a mathematical modelling approach to try and bring all of this together. This is some of the data we're going to put into the model. So here's some data looking at the sensitivity of HSRDT and RDT in different age groups, so trying to understand the different age patterns of treatment-seeking and parasitemia. We also have some really nice data from James McCarthy's lab on the time to negativity after treatment with a antimalarial. So this is time to RDT and HSRDT negativity. And then finally, we've got some really nice data from Senegal on treatment seeking rates for non-malarial fever in different age groups. So we're going to bring all this together within the Imperial College Malaria Modelling Framework to try and get estimates of how many additional cases are going to be detected with an HSRDT. So finally, to conclude, HSRDT is more sensitive than RDT in all the studies. There's no clear trend at the moment between HSRDT sensitivity and transmission intensity. Using an HSRDT for clinical case management could potentially increase the number of non-malarial fevers you're going to be detecting and detecting more people that have been recently treated. But hopefully the take-home from this is that there's lots of interesting use case scenarios, but the first thing we need to do is collate the data and try and understand these processes and synthesize this data to get some sort of conclusive messages about the impact of this new tool. And finally, thank you to all my collaborators.
So are there any clarifying questions, and really just restrict to a clarifying question, otherwise we'll